All right. We are in the midterm this week, but it's not the traditional midterm. It's basically just a traditional assignment. I am requesting and strongly advising that you go through the whole midterm on your own before referencing this recitation and before getting help from the TA. So if you have not completed the entire midterm yet, please don't watch this just for your own benefit. You need a chance to evaluate how well you're learning this stuff. You might think, well, on the final exam, I'll just put the extra effort to get through it. Go ahead and put the extra effort in now so you can get an indication of, are you learning this well enough to get through the final exam? So I'm going to buzz through this pretty quickly. We have a lot to go through. The midterm is longer than a typical assignment because you didn't have any instruction. All right, first things, let's execute these blocks up here. And we have this movies database that has a bunch of movie information. So it says, take a look at rows 1, 4, 7, 9, 12, and 17 of columns 9, 12, 13, 14, 18, and 19. So when you are looking at rows by number and columns by number, it's a lot easier to look at that through base R instead of using a filter and a select statement. So I'm just going to take a look at MVS. And then the rows go first. So I'm going to copy these numbers, paste them into my combine verb there. So those are the rows I want. After that, then you have the columns you want. And this is just showing some of the key columns so we can see what there is to see here. Okay, so we have popularity measure. There's a release date measure, a revenue, a runtime, title. We've got, and then a vote average. So it's got a bunch of information about a variety of movies, 4,803 different movies. Okay, so first thing it asks us to do, let's clean the data. We're going to create a new data set called movies, and we're going to include these columns and include all the rows. So we're not filtering anything. We're just looking at these rows. So we want to create a new data set called movies. And we're going to start with MVS. Now we have a couple options. We can use dplyr, and we will use a select statement to select these variables. That is one option. But because these variables in the list of the instructions I gave you is actually in quotation marks, I can also just do this. I want all the rows, so I just leave the row selection portion blank. The column selection portion, I can just copy this entire list, paste that in here. And since there's no and between these, I can just execute that. And now we have our data set, movies, and I just got rid of 4 of the variables, apparently. Okay, question 3. Let's correct the release date variable that was read in as a character variable. So I just want to take a look at that real fast. So movies, $ release date, and I'll just look at the first, like say 20 of those. And sure enough, we see quotation marks around this in this format, month followed by day, followed by a 4-digit year. I can confirm that as well if I use the structure function on movies. I can see all the different variables here. And if you go to release date, this is a character variable. That's not good for us because we can't actually do anything with the date. So, all right, so let's fix that. To fix that, we're going to say movies, $release date. And we do what we often do when we're reformatting something. We just replace it with itself. So we want movies, $release date. So we're going to replace it with itself. So we're going to say movies $release date is movies $release date, only we're going to format this the way we want it. The way we're going to do that is by say we want as dot date. That's our function. So we want to treat this as a date. The problem is that's not going to work because R doesn't know what is the date format that it's in. How do we interpret these characters as a date? So we actually have to tell R how to do that. So the way we do that is we say format equals. Okay, and here's where we have to either remember or look it up. How do we format the date? Okay, so the dates as read in the data are 2-digit month numeric month, followed by the numeric date, day, and then followed by a 4-digit year. So we do format equals And we're going to put that in quotation marks. So first of all, the 2-digit numeric month is going to be percent lowercase m. After that, there is a forward slash. So when you say after that, you're going to see a forward slash followed by a 2-digit date, and that is percent lowercase d, then a forward slash, and then we have a 4-digit year. The 2-digit year is going to be percent y, 4-digit year is percent capital Y. Okay, so when we do that, now we've replaced all those, and let's take a look at those first 20 again to make sure it worked. How do we know it worked? Well, it's no longer month, day, year. It is 4-digit year followed by the 2-digit month followed by the 2-digit day. So that is the format R likes. And now we can also use the structure function again, and turns out, yeah, release date is now coded as a date. Okay. All right, we're gonna explore the data, examining a few distributions. So we're gonna do both a histogram and a box plot of the revenue variable. That should be pretty straightforward. We first do our data equals movies, then we do our aesthetic statement. We say X equals revenue. And then for a histogram, we say geom underscore histogram. Take a look, we can see this looks pretty right skewed as it is. It's actually even more right skewed than that since it goes way out here. There's a couple points out here that are too small to even see. But yeah, most movies don't make that much money, but then some make a lot of money. Okay. Now to do a box plot, we can copy all of this and just change this to geom underscore box plot. But that gives us a horizontal box plot because we said X equals revenue. So traditionally, a box plot is going to be on the Y dimension. And this is so right skewed that the box plot is totally uninformative. You don't want your box to be so smashed you can barely see it and then just have a bunch of outliers. So this is a really terrible plot. If you were actually going to report this to somebody to give a sense of the distribution, you wouldn't want to use this plot. Either of those plots probably. All right, the distribution of the movie revenues shows a high degree of right skew. Now it just asks us what movie had the highest revenue. Okay, so that, if you're going to use dplyr for that, we can say movies, and then we'll use our slice max, and we're just looking at based on revenue, and we just want the highest one, and that was Avatar with revenues of almost $2.8 billion. I assume that's worldwide. I want to show you one other way in case you're working with dplyr, or you don't have dplyr installed and you want to do something different. Then you can also say movies, and I just want to look at a single row. So I want only the row where movies $revenue is equal to the maximum movies $revenue. This is the way I always did this kind of thing before I actually learned dplyr. Okay, so getting the actual projector going here. As you can see, nobody's here today, so I'm actually going to go ahead and put that on the screen, even though it's not needed for anybody, just so the video looks a little less weird. Okay, show the distribution of vote average. Okay, we're going to do a histogram on that. I frankly am not 100% sure what vote average is and what that's based on. I assume that's the IMDb score. I think that's what it is. So we say ggplot, again, data equals movies. Our aesthetic statement, it's a histogram, so all I have to do is say X equals vote average. And then we do histogram. Okay, so we can see vote averages. We have a little bit of almost left skew there. We have this mass point at 0, which I don't know if those are movies that have 0 ratings or if those are movies with a few 0 ratings, as in people who actually rated it a 0 out of 10. And then we have kind of a pretty big mass up here, very few with a 10. I assume these movies with a 10 rating are people with like movies with maybe 1 or 2 total ratings. So the next question is, was the highest grossing movie also the movie with the highest vote average, right? If it's a movie that is super, super well liked, is that what led it to be the highest grossing movie? Well, Avatar did have a pretty high vote average. If we look over here a little bit more till we find our vote average. Vote average 7.2, that's quite high on this distribution, but it's certainly not the single highest vote average. So the answer to that is definitely no. All right, now it asks us, create a scatter plot with vote average on the x-axis, popularity on the y-axis. So think about that for a second. Why would that be meaningful? Vote average is a measure of how many people, how much people liked it on average. And then popularity on the y-axis is another measurement that should be affected by how well liked the movie was. So I would expect some kind of positive correlation there. If it's more popular, it should have a higher vote average, but let's take a look and see. So we're going to say again, data equals movies. Our aesthetic statement, we're going to say vote average on the x-axis, popularity on the y-axis, and then this is going to be a scatter plot, which is our geom underscore point. Okay, and this, because of the weird nature of the popularity variable, we've got this incredible right skew up here. I don't even know how that is measured. But it's hard to see if there is a positive correlation. I wager there is a positive correlation here, but these numbers, this is all smashed down so much because of this skewed nature of popularity. It's hard to see if this is a really good positive correlation going on there. Okay, just gonna move on. Often people complain that movies are not as good as they used to be. So create a scatter plot with the release date on the x-axis and vote average on the y-axis. So that would show, okay, as we move along in time, does the vote average decline, go up, stay the same? So again, this should be pretty straightforward. We're getting lots of practice on these plots. Data first, followed by our aesthetic statement. X is release date. And that shows you one of the values of converting our release date to an actual date is we can actually plug this in as the X variable. If it were the character variable, no dice, that wouldn't be possible. So Y is our vote average. So is the average liking or appreciation of a movie, what is that doing over time? So again, this is a scatter plot, so we use geom point. And we see it runs the gamut over time, except that because these older movies, there's fewer of these really not well-liked movies down here. So we do seem to see some negative trend there. These points are so piled on top of each other, it's hard to see where the real mass is, but it does look like there's a little bit of a downward trend there. So but then we also see here these movies out here, which is like 2030. There's like these 4 points out here. That's just kind of bad form. These are movies that this movie database was published in 2017. So these are movies that have not been released yet or never got released, or I'm not 100% sure, but let's not plot them because at the time this database was released, clearly these movies hadn't been released. So let's get rid of those points is what we're asked to do next. And the way we're going to do that is we start with movies, and then we want to get rid of those 4. So we're going to use how do you get rid of rows in a data frame? We're going to use a filter statement. So we're going to filter, and we will say we want movies that were released prior to January 1st, 2017, or prior to the end of 2016. So we just want release date must be less than, and here's how we're going to do dates. 2017-01-01. Okay, remember year, month, and then day. Okay, so now that we've taken out those future release movies, now we can do our plot. So we're pipe that into our ggplot, which means we do not have to start with our data. We just start with our aesthetic statement. We say X. Again, it's going to be the same thing we did before. X is the release date. Y is the vote average. Again, we're doing scatter plot. This is geom point, not geom point. Okay, so same thing we just saw, just we're using the x-axis a little bit more efficiently because we're not wasting all those years with those movies that hadn't been released yet. Okay, so we do see some decline here. So are movies getting worse over time? Frankly, I don't know, but I do think there's an alternative explanation to this pattern that we're seeing. Um, and as I clue you in on the instructions, it probably has to do with his next plot. So let me see this. We think the data have a recency bias. More films, it shows way higher concentration of the newer films than the older films. And that's pretty obvious when you see this here. There's a lot fewer points in these older ranges than here. Okay, so what we want to see is, hey, how many movies were released in every year? Show me with a histogram. But it says, make the histogram show 1 bar per year using this bins command. Okay, let's start with the histogram and then figure out how to do 1 bar per year in a second. So we're doing a ggplot. We're using our movies data, except we only want movies from 1930 to 2016. The oldest movie is 1930, I think, so we don't have to filter there. We're going to start with movies, and then let's filter out the movies again that were released prior to January 1st, 2017. So I'm just going to copy this. So we want our release date to be prior to that. We're going to pipe that in to our ggplot statement. And we don't need our movies data because we have already piped our data into that. With the histogram, we only specify the X. So we're going to say X equals release date. So we just want the number of movies released in every release date. We make this geom underscore histogram. And that gives us the histogram, but it doesn't make the histogram have 1 bar per year. In order to have 1 bar per year, we're going to say bins equals, and then the number of bins we specify needs to match the number of years represented in the data. I already told you, starts in 1930, goes to 2016. How many years is that? Well, up to 2000 would be 71, right? So plus 16. So 71 plus 16 is 87. So pause that and think about that for a second if that math wasn't obvious to you, but 1930 up to 2000 is 71 years plus the additional 16. So 87, and we can see we have all these recent movies. Most of the movies released post 1990 are represented here, and very few of the movies from before that are represented. How were these older movies selected? You might think, hey, maybe they just didn't release that many movies back then. Just the opposite, frankly. Back in like the 1920s, they used to release one movie every week, and people would go to their local movie theater and watch the one movie that was available. So there were tons of movies released in earlier times. So why are these movies here? That's called selection bias. These were selected because these are the greatest hits. So when we look at this plot up here, notice the vote averages are quite high on these movies because that's why they are in our database. Only the best movies from prior to 1980 are even in here. That makes it look like movies are getting worse over time. It's just that we have selected our data to represent the better movies from the older years. Okay. All right. Number 12, we're going to do something new. This is something we have not done. I never actually told you how to do this in the instruction at any point prior to now. On your assignment, I give you a paragraph explaining how to do it. So I hope you're able to use that instruction to actually create these new variables, release year and release month. If that was confusing to you, well, I'm telling you now. So we're going to create new variables inside the movies data frame. So we're going to say movies, $ release year. Okay, and I want that to be, again, we're replacing sort of itself. Release, we're going to start with movies, $ release date. Okay, I only want the year portion of that. The way I do that, how do I extract the year? All the release date has that year is the first 4 digits. I could, I'll show you something. This is not the way I recommend doing it, but we could do, okay, substring. Substring is a command that lets you just take the first few characters. I could take, and then I could go from movies release date, and then I can go from the first to the 4th character and just extract that out. But substring only works with character data. This is date data, not character data, so we can't use substring. We're actually going to use format. So notice when we actually inputted our date up here, we said, where was that? Number 4, I think. Or was that number 3? We said format equals, and we put it in here. There's actually a command called format that we can do with a date and actually say, here's what we want to extract. All I want is the year information, which is %Y, capital Y. It's going to extract the year for movies from the release date and then save that into this new release year variable. So if we take a look at, I'm just going to do this quickly, the first 10 of those to see if that worked. What do we find? Okay, so now our release year variable has 2009. It's extracted the year from the release date, but there's quotation marks around it, which means it's formatted as a character variable. How do I format it as a numeric variable, like it asks us to do, format release year as a 4-digit numeric variable? I replace it with itself again. Movies, $release year is going to be movies, $release year. I'm going to replace it with itself. Only I will say as dot what. Okay, we just learned that this as dot function lets us do almost all sorts of different formatting things. As dot numeric. Okay, most of the as dot formatting stuff is lowercase, as dot numeric, as dot character, as dot integer, as dot Boolean or something. Most of those are underscore or undercase. So as dot numeric, as dot date is the one where we use a capital D. So when we do that, and then if we take a look at the first 10 of those, now there's no quotation marks around it, which just means now it is a numeric like we want it. I'm going to delete this bracket 1:10 because if you turn in your assignment and that's still on there, it's going to mess things up. Okay, now we also want this new release month, release underscore month, which we're going to do the same thing we did before. You use format. We're going to format this release date variable. And instead of extracting the year, we want to extract the month, which is going to be %m, lowercase m. Okay, and now release month, if we just look at the first 10, release month is a character variable. And it does say leave month as a character variable, but it should be numbers. So we do see the numbers, just the numbers are in quotation marks, which is what this asked us to do. So we're not going to convert that to numeric. We're just going to leave it character. Okay, now we have these useful new date variables, the release year and the release month. And now it says create a report showing the highest movie budget in each year from 2000 to 2016. Okay, so let's start with what we know. Okay, we want the highest movie budget each year from 2000 to 2016. So first things first, let's filter, right? So we know we don't want years prior to 2000 or post 2016. A couple ways to do that. We can use release date, or we can also use this new release year. So we can say we want release year to be greater than 1999. And we want release year to be less than 2017. Okay, all right, that takes care of that. Okay, how do we extract the highest movie budget each year from 2000 to 2016? So that is a calculation. Whenever we're extracting something, we can use a summarized variable with the max calculation. But we want a different calculation for every year, which means we're going to do a group by release year. Then we can follow that up with a couple options. We can do a summarize statement, and that will only give us the top highest movie budget in each year. Or we can use a slice max. If we use a slice max, it gives us all the data. This was actually agnostic. It didn't tell us whether you want to keep everything or not. So I'm just going to do slice max so we have all the other data in case we're curious about where these movies are coming from or where these high budget movies, which movies the high budget movies were. We do slice max, we want it based on budget, and we just want the highest one from every year. So now we can see the highest budget movie in 2000 was Dinosaur. That was probably not a great investment since I forgot that movie even exists. Pearl Harbor in 2001, Die Another Day, and Men in Black both had the similar estimated budgets. So they were tied, actually 3 of them. And Treasure Planet as well, another not good investment. All right, so now we see these maximum budgets from every year, and on the next question asks us, create a line plot of this data. Okay, so to do a line plot, we need this data, not the actual original movies data. So we could either save this in, some new data frame, or we can just copy all of this and pipe that into a ggplot statement. I'm going to do that. Pipe that into my ggplot statement. Since I've already piped in my data, I don't have to specify my data. Go straight to my aesthetic statement. I want my X to be what? I could say release date, but then, these high budget movies are released on different places throughout the year. I'm going to base it on release year. And then I will say Y is my budget. And I want a line plot. So that's geom_line. Okay, and we can see we had this weird 2011 year, had this incredibly high budgeted movie, but we can see, we think probably an increasing trend, even though it's noisy, as you might expect, data typically is noisy. All right, now question 15 asks us, hey, Hollywood tends to release their biggest movies in summer or in December. So let's take a look at the mean and median budget of movies by month of the year. Not by month and year, but by month of the year. So I want all of the December movies, all of the November movies, all of the October movies grouped together across those years, 2000 to 2016. Okay, so first things first, we know we want to filter by the same thing. We only want movies from 2000 to 2016, so I'm going to copy that. Okay, next, we want to report the mean and median by month. Anytime we do a calculation by year, we're going to do a group by followed by summarize, right? Group by, now we want release month. We want a different calculation for each month of the year. And then we do a summarize statement. We want, I'll call it mean budge is going to be the mean of budget. And then I also want the median budget. So median is going to be median of budget. Okay, when we do that, we see that these numbers are a little harder to interpret because we have the scientific notation that makes it more difficult. But with 6, that looks like 6, that's 4 million is the median. And here we have 15 million is the mean. Here we have 20 million. This is in February, 26 million. Summer, you can see the numbers go up in May, June, July. We have these high numbers here, but they are much higher than the median always, and that is pretty classic for right skew data. Okay, now we're going to do another report. It says create a report that shows for the movies from 2000 to 2016. We want the total movie revenue for the year, the revenue of the highest revenue movie of the year, and then we want this percentage calculation. What percentage of the total revenue came from that single movie, right? So the highest revenue movie. So anytime we're doing a percentage calculation, it's going to be a mutate statement where we have the total, we have that, and then we're going to put that in there. So we want for every year from 2000 to 2016. So we're going to start again with this filter statement. Okay, and then we're going to say, all right, group by release year, right? That should have been pretty obvious. If we're doing a calculation within each year, got to group by that year. Now, next, what do we want to do? Do we want to do a group by mutate or a group by summarize? Now, remember, group by mutates are really useful in that they put in whatever total you calculated back into the original data so that you can do some kind of percentage. The thing is, we're not doing a percentage for every movie. We're doing a percentage of just the highest revenue movie. So we're actually going to use a summarize statement here. And then we want the total movie revenues for the year. So we say tot rev is going to be the sum of all of the revenue, right? So with every year, we're going to sum up all the revenue made by all the movies in our data set. We want the revenue of the highest revenue movie of that year. Remember, the summarize statement lets us do a max calculation as well. So we can say max revenue is going to do max of all the revenue, all the revenue data. But because we have group by year, that's going to give us, 17 different maxima. And then finally, we want this perk rev. So how much of the total revenue came from just that highest grossing movie? Well, we have that in max rev. So perk rev is just going to be max rev divided by tot rev. Okay. And that's it. So we needed a group by summarize in this case, not a group by mutate. Even though we're doing that percentage, that usually clues you into calculating percentage. We want to do a group by mutate. In this case, we didn't actually need the mutate. So we see in general, the highest revenue movie tends to bring in 5 to 7% of the total revenue for the year, except in the Avatar year. We had Avatar pulling in over 13% of the total revenues for the year came from just that one movie. Okay, number 17 asks, let's take a look at the distribution of movie budgets within the year 2012. So let's create a report called DIST-12. So this is going to be called DIST-12. And we want that to be to list all of the movies released in 2012. That includes title, revenue, budget, tote budge, and perk budge. So we want tote budge to report the total amount budgeted to all movies released in 2012. And that is so we can calculate this perk budge variable that's going to report the percentage of the total budget contributed by that movie's budget. So what is the distribution of movie budget across all movies that were released in 2012? Okay, so it might not be obvious how to do this. Let's do what is obvious. Let's just look at the movies in 2012. So let's filter and we say release year is going to equal 2012. So double equal sign there. Okay, so we've taken all our movies of 4,800 and got it down to, I don't know, 300, 400 that released in 2012. I don't know what the number is, but so we've got these 2012 movies. Now what do we want? Is we want the total budget. We want to add up all of the budget made across all of these movies in 2012. We want to put that in every row so that we can say, okay, what was the budget for this movie divided by the total budget gives us the perk budget. Next movie, this was the budget for this movie divided by the total budget. Okay, how do we do that? We usually, if we want a calculation put in every row, we do a group by mutate. Okay, so we do group by what? Well, we want the full calculation to cross the entire year, but we only have 1 year in this data set. So we don't need our group by. We can actually go straight to the mutate statement, and we want tote budge. It says lowercase, so tote budge is going to be a sum of all of the budget numbers. Okay, so that will calculate all the tote budget, but because it's a mutate and not a summarize statement, instead of just giving us that number, 1 row, it's going to calculate that sum and then put it in every row of our data. Once we've done that, we can calculate perk budge, which is going to be the budget of the movie in that row divided by tote budge. Okay, so that will do the calculations we want, but then it actually says, that also says in the instructions, just include these 6 variables. How do we select a few variables? We use the select statement. We want these 6 variables, so I'm going to just copy and paste those into my select statement. Okay, so to recap, we start with movies. We just look at year 2012. We want, in order to calculate the percentage of the total budget that came from a particular movie, we would need to calculate the total budget. So we use a sum within a mutate statement that calculates the sum, and instead of just reporting the sum, it puts it back into the data, which lets us calculate this perk budge, and then we just use that select statement to just look at the variables we want. That was saved in DIST-12. We always want to look at something we just did. So in 2012, we had 3.5% of the budget came from The Dark Knight Rises. Another 3.5% went to John Carter, another unfortunate investment. 3% went to the Avengers. And that seems like, well, it seems like it's going to add up to more than 100%. But if you go farther on in the data, we have a lot of really low budget movies. So this was 0.5% went to whatever movie that is, Man on a Ledge. And then if you go lower down, we've got these movies that got, really, really small budgets. Okay. Moving on to question 18. How many movies use the word beauty in its title? Okay, so in order to look for a character string, we use grep or grepl. I like grepl because it returns a logical variable, it turns true and false, which is nice for doing counts. So the 2 inputs to grepl are, what are we looking for? We are looking for beauty. Okay, so that is the first thing, is that pattern. You can see grepl first is the pattern you're looking for, and where are you looking for that? I want to look in movies, $ title. Okay, this is going to return a vector of length 4,803 trues and falses. If I want the count, I can just sum all of those up. And I'll take this vector of 4,803 trues and falses. Those get coerced to ones and zeros. I sum them all up, and that gives me how many use the word beauty in its title. And it comes back 0. Well, I know there was a movie called American Beauty, and there's a couple others, Black Beauty maybe. So there certainly isn't. Well, that's because I spelled it Beatty maybe. Okay, beauty, still 0. What's going on? Well, grepple is case sensitive. So we know that's 0, so we don't have to worry about lowercase beauties. Uppercase beauty, there are 4. Okay, on your assignment is looking for something else. And be aware that if you include a space, it's going to look for beauty with a space behind it. So when I do that, it goes from 4 down to 1. So it turns out there was a movie with beauty and then another word following it. So there was a space there. But I think 3 of the movies ended with beauty, which means there wasn't a space bar following it. So if you look for beauty with a space, it gives you, it returns false. Okay, so you have to be very specific. And if you're looking for beauty, does any of them have like beauty colon and then something following that? No, that doesn't happen. Can you look for beauty period? Yes, you can. Oh, there is a beauty with period behind it. The problem is, like, where was that? I'm not sure what movie that is. Why would there be a period in the title? Turns out period is kind of weird. Period lets you specify these other characters. So if you do a double backslash, that actually says, hey, don't use period as like a special character. I want to actually look for the character, the period. And then it goes, okay, well, there aren't any movies with beauty that have a period in the title. Okay. So those are the things I want you to keep in mind on the assignment. It asks you to look for, I think, America, but it doesn't. You also need to look for America with a comma after it, and then you're looking in the synopsis, or the description, not in the title. So there's times where they use the word America with a comma or with a period, and you want to include those, but not American. So you don't want to look for American. You want to look for America, America with a space, America followed by a period, or America followed by a comma. Okay, how many movies have had a title change? This is actually pretty simple. All we need to do is say, all right, movies, $title equals, double equals, movies, $original title. Okay, if they're the same, then they didn't. So this will give us a bunch of trues and falses. How many had a title change? All right, well, that means we'd want them to not be equal. And if we do that, we're going to get, again, a vector 4,803 long. I don't want to count all the trues I see in there. So in order to get a count of them, I can just sum all of this up. And we see 261 movies where the title is different from the original title. All right, question 20. This is the question that's going to be the most difficult. And actually, so this is going to be an exercise for you, but it's a worthwhile exercise. Okay. The studio wants to compile a list of movies that overperformed in theaters. And the way they're defining overperformed is we're going to find a movie that was below mean in popularity. So it wasn't a super popular movie, like whatever popularity measures. So it was low popularity, but still made more money than average. All right, that is something worth studying. If we're a movie studio, like what is it about these movies that made people come in to watch them despite them not being popular? That's something we want to replicate, right? So what is driving people to go watch these movies in higher levels than would be indicated by their popularity? So we're going to create this variable called overperformed. We want it to be true for movies that fit this characteristic of low popularity, high revenue. Okay, so I'm going to stop there or just go to here. And I've given you something called pseudocode. So pseudocode is language describing the step-by-step code and what it should do. So, we're going to follow these instructions step by step. But first it says, hint, your code is going to return an error if you have any single movie that has NA for the release month. It turns out we have one movie that is missing a release month because the release date was poorly formatted or something. So we're going to get rid of that first. So I'm going to say movies. I'm going to replace it with movies, but I'm going to filter and I'm going to say is not missing the release month. Okay, so that, notice now our movies has 4,802 observations. So that's just going to get rid of a problem that's going to come up later. So first things, we want to save trues and falses into this overperformed variable. So I'm going to pre-allocate this. Movies, $ overperformed is going to be a true false variable. So I'm just going to use my replicate and I'm going to fill it in with falses at first. And then how many do I want? I want 4,802 of them, but I'm going to say n row movies so that my code is usable for another database or another data frame with a different number of rows as well. Okay, so now we've got in the very end of our data frame, the very last column is this overperformed variable that is filled with falses right now. Okay, that is going to be helpful for us because now all we have to do is look for the condition we want of overperformed and change that to a true. Okay, so the first thing the pseudocode asks us to do is loop across the movies in the data set. All right, we're getting some for loop practice. So to loop through the movies, we're going to say for I in 1:4802. Only again, to make that usable, I'm going to say n row movies. Okay, so that is my, in the parentheses, my looping behavior I want. Follow that up with curly brackets. Okay, so we're going to loop through the movies row by row, all 4,802 movies. Okay, and each time, every time we see a new movie, we're going to say, if the movie's release date is after 2016, return false. Or only have the potential to return true if the movie's release date is before 2016. So I want to check, is movies $release date less than 2017? Okay, if it's not, I don't have to change anything. All I have to do is just leave it as a false. Since I filled in the overperformed variable with falses, I don't actually have to fill it in with a false. It's already filled in with false. So if it's less than 2017, I'm not, if it's, it was released after 2016, then I don't even have to do anything. In fact, I just realized an error there. This is release year, not release date. So if the release year is less than 2016, I can continue to analyze it. There's another mistake here. Movies $release year is a vector 4,812 observations, 4,802 observations long. I only want to look at each movie one by one. Okay, so only if they were released prior to 2017 do I even want to look at it. Okay, if then I want to check whether the movie's popularity is below the mean popularity. If it is, then I'm going to move on. If not, I just keep it as a false. So if I want to check if the popularity is below the mean. So if movies $popularity bracket I. So I'm just checking this movie. Is that popularity less than the average popularity? How do I get the average popularity? Mean. Mean of movies $popularity. Okay, if that is lower, so that is the first portion of our definition of overperformed, it is below average popularity. If it is below average, then I'm going to check my other condition. If a movie, for a movie that is below mean popularity, check whether its revenue is above the mean. Okay, so an overperformer has to be below popularity, but below mean popularity and above mean revenue. So if movies $revenue, so if the revenue of this movie, so bracket I, if this revenue is above the mean of all of the revenue variables, revenue data, okay, in that case, we have filled all of our specifications. It was released prior to 2017. It is below mean popularity. It is above mean revenue. In that case, we're going to say movies $overperformed. Bracket I, only this movie. If this movie fits all those criteria, then this movie will get T. We'll change that false to a true. Okay, so this is actually what you are being asked to do on the assignment. Just follow the pseudocode. That's going to look something like this. It's going to use slightly different variables. I think they're both using the mean calculation here. And you're going to, qualify all of these using this loop and this variable here, right? This set and look for overperformed or underperformed. I'm not sure which that you're looking for in the data set. Okay, and then it says how many movies qualified as overperforming. That again, because it's true and false, all we have to do is sum them up. Some movies, $ overperformed. And we have 263 movies that qualified as overperformed. Okay, on the extra credit, this is one of the extra credits that you will see in the assignment, but there's an extra credit before that one. And your extra credit looks like this. There's one thing we're missing here. We want to check, it says, if the movie is below mean popularity, check whether its revenue is above the mean of movies released in the same month. Right? So we're saying, hey, this is an overperforming movie. It was below popularity, but it made more money than other movies on average. This actually asks you to say, does it make more money than movies released in the same month? Because if a movie was released in February and it overperformed, it did better than it would have expected to be performed. Well, February is not a high movie watching month. So let's say this movie made $30 million. It might have well overperformed because most movies that released in February, on average, February releases make like 10 million or 20 million, and this movie made 30 million. But if you're going to compare it to all the movies, you're going to compare it to the movies released in December and July that make an average of 50 million. Right? And so that's not a fair comparison. To make this more fair, we want to say, okay, is this movie greater than the average of the movies released in the same month? Okay, so here we're taking a mean of all of the movies, all 4,802. I actually want a mean of only the movies released in the same month. So I want to take this movies $revenue, and I don't want to take all 4,802. I only want the movies released in January, if it's January, February, if it's February. So we take this big thing, and I want to say, I want to check movies $release month. I want movies $release month to be equal to, I'll just put it in for now, 1. That would be, I want, or actually I would have to do this, right? 1, because release month is a character variable. Okay, that would be, hey, I only want to compare it to January. So what this does, take a look at this, make sure you understand. Movie $revenue is a single column of our data, 4,802 observations long. Okay, if I put in brackets and then I say, hey, I want the movie's release month to equal 1, I'm only going to pull out the movies where release month was January, and then I'm only going to take an average of those, and that'll compare the average revenue to the average revenue of movies released in January. The problem is not all the movies released in January, clearly. So I want this to be whatever the release month was of the movie I'm looking at right now, which I can do by saying movies, $release month, bracket I. Okay, that might take some extensive study to wrap your head around this if you want the extra credit. If you don't want the extra credit, you don't have to bother with this. But I hope you can puzzle through this. This is not something that everybody's minds are going to immediately latch onto. Some of you might go, oh yeah, that makes total sense, but that's not the majority of you, I'm guessing. Okay, so movies $revenue, that is the big column. We're gonna limit it to movies where the release month, this is another column, the release month equals whatever the release month of this movie. So I'm looking at this movie right here, and I want to say, okay, what was the revenue of this month? How does it compare to the average revenue of movies released in the same month? Where I say movie revenue, and then I'm going to look at only where release month equals this release month that I observed in this particular row. Okay, so so I can say, okay, I equals 1. If we're looking at our very first one, movies $release month bracket I, only the first bracket is 12. Okay, that movie was released in December. So if I say movies $release month equals that, I'm going to get a bunch of truth and falses. So then it's going to say, hey, I only want the first month, or the first movie, the 20th movie, the 23rd movie, 24th movie. Those movies are the ones I'm going to take an average of. So then when I do movies $revenue with all of that, I only get 460-ish, 457 or so movies. And then I take an average of those movies that were released in December, and the average was The average revenue was like 111 million. That seems like a lot to me, but 111 million was the average revenue of a movie released in December. Okay, and so now if you got a December release, I'm comparing it to movies released at the same time frame. Okay, again, that portion of your assignment is extra credit if you can figure out how to do controlling for by month. But I hope that was useful for you to look through. And then this extra credit, if you use G-sub here and figure out how to use G-sub to get rid of all this extra data so you can look at genres, there's some more extra credit for you there. Okay, good luck.